In this video we're going to look at completing this block from an earlier video. This time we're going to look to include the isometric cylinder that's on the top of this block. We're going to start off by creating a crate for this block to fit into, similar that we've done in other videos. To create the crate, what we're going to do is we look first of all at the maximum diameter of this object here. We get an indication just in terms of space in between the edge here and here as to what size it's going to need to be. So it's only a couple of millimetres there. Obviously I've drawn this at a bigger scale, so I'm going to look to exaggerate that slightly, but not dramatically. So I'm going to look for how much it comes in from that side here, probably about that much, and I'm going to continue to add that parallel line here, here, and then the same distance along the back edge and the front edge, keeping parallel the whole time. That gives me a box, first of all, that I'm going to start off with. I'm then going to extend the heights to the maximum height. I'm going to ignore the little slope in chamfer just now. I'm going to extend to the maximum height, so looking at that top height here. And again, trying to compare that height with others that I've got. So the distance from here to here is probably about the same as there to there, adding on another little bit there. So I'm going to use that as an indication of how tall I should be going. First about there, and then a little bit taller. And I'm going to extend that height up at the front and here as well. Now, to make sure I've got that height consistent all the way along, I'm going to aim to be parallel to the front of the object here. And then from that intersection, I'm going to go back, maintaining parallel, so I'm not trying to join to the top of that line, I'm just trying to go parallel. You can see I extended a little bit above, so I'm going to look for where they cross over now. And just as I've done in previous videos, once I've got the heights around the front, I'm going to extend a 30 degree line going back from that corner and 30 degrees going back from that corner to get a box to close in at the top. So going back at 30 degrees, and then from this corner here, going back at 30 degrees. For clarity, I've lined a couple of lines around the back just so it doesn't become too confusing. But what we're going to start with now is trying to get a circular shape on the top of this crate first of all. Now, we're not going for that narrow diameter circle. We're imagining this chamfer is not there and that this circle extends right to the very top height so that we can subtract off the chamfer later on. Now, just as we've done for 2D sketching, the first stage is to try and find the centre of this square face at the top. You can do it either by joining corner to corner, which is more accurate, but it is going to add an extra couple of lines in. So we'll start going from corner to corner, and then using that as a guide going from the middle through the centre to the other side, and looking for the middle of this back edge, going through the centre to find the front. And this process is exactly the same as we used in 2D sketching. We're going to treat it as being point 12, point 3, point 6 and point 9 on a clock. So we know we're going to have the curve passing through here, here, here and here. And then to find how the curve would follow around here, along the top and around the other sides, what we have to do is we have to look to this line here first of all and divide it in two. So looking between here and here, and halving it, and then looking from there to there and halving it again. And what that does, it gives us about 3/4 the way along. And what that would allow us to do is pass our curve for the circle through there. Now, it's important to note that when you're drawing or sketching an isometric circle, it doesn't look like a circle, it looks like an ellipse. So you'll see that it will appear more squashed at the top with a much flatter curve, whereas it will be a much steeper curve on the right and left hand side. But let's use the same technique again. So going between here and here, finding halfway on this line, which is about there, and then halving the distance from there to there. And at this point, I would be able to sketch a curve through that point and get to here. And you can see the difference between a much flatter curve and a steeper curve at the sides. I'm now just going to complete that process round the other two sides. So again, finding halfway between here and here, and finding a point there and doing the same down here to complete the process. You can see now what I've got is an elliptical shape up at the top, and what I'm going to do now is I'm going to extend first of all this point here, so the 9 and the 3 down to the bottom there, and the same for that one here. Now the next task is to look at the next intersection point, so that one between 3 and between 6. And what I can do is I can extend that down, but what I'm going to do is I'm going to extend it down and stop just short of that bottom line. So I'm going to look at how far it is from here to here. I'm going to try and replicate that down at the bottom, which is about that, because that will give me an indication of where the curve would be at the bottom of the object, trying to mirror that exact same curve. The same I'm going to look between there and there, so this intersection point here and this intersection point here, and look at the gap between the intersection and the curve, which is about here. Over at 9, it sits on the edge of the line, and then I'm going to bring this one down, again stopping short of that line, looking to try and replicate that gap here and here, which is about there. And what it would allow me to do is sketch through there and through to the bottom and try and smooth that out. Basically what I've been able to do there is try and create a curve that follows the same path as the one at the top. Now at the moment that gives us a cylinder that is full height and doesn't account for the little chamfer or the fact that it's got a narrower diameter at the top, which we're going to look at now. To add in this narrow diameter circle, we're going to look at it first of all as an isometric, and what we're going to do is we're going to look at that height change, that difference between here and here. First we're going to add this curve here. It's obviously slightly lower than the overall height. So to do that, I'm not going to mark any extra points, I'm just going to follow a path similar to the one at the top. I'm going to start by marking it on that central height line, and then I'm going to work to the right, and you can see it gets quite steep into the corner there, and then I'm going to follow that round out to the side here. The next part of the process is to add this circle here. Now viewed like that, it's obviously at a slightly different diameter. We're going to narrow that in, looking at the difference in the two diameters in a plan view, so you can see it's similar to the change in height. I'm going to try and mirror that all the way around, and I'm going to sketch that curve in, again not marking any points, just trying to follow the same path on the outside. This time having shorter sketch lines but trying to keep them smooth and consistent, trying to avoid making them look scribbled. So I'm going over the same lines repeatedly just to make sure it's consistent. And what it does is it gives us the internal diameter, and then it gives us that external diameter below. And once we have those two, what we're able to do is simply join those corners. It's not a direct join, so it's not a straight angle. There is a slight transition to it, so you almost curve the bottom and allow it just to follow and blend into the top. And the same with this corner here. And for clarity, I'm now just going to go and line that in. And you can see what we end up with is a pictorial view, a three-dimensional view, allowing us to see the length, the depth and the height of the object, this time including a cylindrical shape up at the top, including a quite difficult chamfer to add in. But the process without the chamfer would just be exactly the same. If you're just doing a normal cylinder, you would extend to the top, and rather than having to do that internal diameter, you would just keep create your top height crate and allow that to be your external diameter and extend down in the same way. So having those heights consistent all the way around, but just using that process of dividing it up diagonally and then horizontally and vertically, and adding your points at 12, 3, 6 and 9, and then finding those midway points to guide your elliptical shape which forms your isometric circle up at the top.